And for part C, we are given the function y as x squared minus 2x minus 8. What is the formula when we are differentiating from first principles? The formula is that the y dx, this is a general formula, is given by limit as h tends to 0 for the function f of x plus h minus f of x over h. So let us see how we can solve part C accordingly. So for part C, the function y is defined in terms of x. So we just say let y be f of x. So we are saying the function y, which is defined in terms of x, is the same as the function defined in terms of x, which is f of x. Therefore, f of x becomes, we substitute, this is the function of y, which we are substituting as the function f of x. That is a squared minus 2x minus 8. This is what we need in the formula. Also in the formula we need f of x plus h. How do we get f of x plus h? We simply get it from the function f of x. What do we do? Where we find x, we put x plus h. So here we have x, so we shall put x plus h. But remember it is squared, so we square. X plus h corresponds to x. And then minus 2. Again, instead of x here, we shall put x plus h. And then we say minus 8, which is independent of x. Then from here we need to expand and operate the brackets. You can use the first method or Pascal's triangle or binomial expansion, but operating the brackets saves time. So here we shall have x squared plus 2xh plus x squared, and here minus 2x minus 2h minus 8. So this is the expression for f of x plus h. Now we have it here. So the formula says that we need to say f of x plus h minus f of x. That means this minus that. So therefore we need to find f of x plus h minus f of x equals to, now and this is f of x plus h, which is x squared plus 2xh plus h squared minus 2x minus 2h minus 8. That is just f of x plus h. But now we are subtracting, so minus f of x. F of x here has 3 terms, so we put them in a bracket. Here we shall have x squared minus 2x minus 8 in that manner. Now we need to simplify that. Now this negative here will make x squared negative. So x squared, which is going to be negative in this case, will cancel with positive x squared. That is 1. 2, this positive 2x here, this negative 2x here becomes positive, because negative times negative, it is positive here. So this positive 2x now will cancel with negative 2x. Pay attention to that. Now this 8, which is negative here, it will become positive because of the sign outside. So this positive 8 here will cancel with negative 8. So what are we left with? We are left with 2xh plus x squared minus 2h. We are left with this, and that. That is the difference of the two functions, f of x plus h and f of x. So after getting the difference, then we substitute for them in the formula. Therefore, our dy dx here becomes limit as h tends to 0 for the difference of the two functions, that is 2xh plus h squared minus 2h over this over h in the formula out of h in that manner. So let us divide all the terms by h. That gives us limit as h tends to 0. Here we shall have 2x plus h minus 2. Shall have 2x plus h minus 2 in that manner after dividing all the terms by h. Now, after dividing the terms by h, then we say h tends to 0. So where we find h, we say h is 0. Therefore, the answer becomes dy dx equals to, the moment we are turning it to 0, don't show for us the side of the limit. Let's say 2x plus h, which is now 0, minus 2. That gives us 2x minus 2. And this is the answer. If you want to check whether your answer is right or not, then you say check. You have the function y equals to x squared minus 2x minus 8. You can use the methods of powers. Therefore, dy dx here equals to 1 times 2 x power 2 minus 1 minus 2 minus 1 x power 1 minus 1 plus 0. If we differentiate the constant, it gives you 0. That means we shall have 2 x power 1 minus 2 x power 0. This is the same as 2x minus 2. So when we are differentiating from first principles, before you leave your answer, quickly check using the methods of powers and coefficients. And this is the solution to part C.